morning, everybody. I'm here to talk about regular expressions, and this is one of those topics where I really wish we just had USB ports and we just download it, because there's so much here. My name is Jeremy Holland. I've been a Perl programmer for longer than I care to admit, going back to systems running 4.1.1, which is terrible if you know what that is. These notes are available at that URL, jeremyholland.info, regex.html, and you can email me at Gmail if you have questions, which you will, because there's a lot here and you probably won't have a lot of time for questions at the end. Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have two problems. This quote, which I love, by J.D. Zawinski, says two really important things about regular expressions. First is how powerful and versatile they are, and second, how dangerous, how complicated they are. It's a very complicated topic that, well, we'll see. They are, in fact, one of Perl's most powerful features. They're really a whole programming language, complete with loops and conditionals and variables and everything, all built into Perl. Every time you see those slashes in that little string, that's a programming language being run with a separate little engine running it. There can be a whole graduate level course on this. We're going to focus on practical use here, and I hope that you'll absorb a lot of this. Regular expressions are primarily used for three things. First is matching text against a pattern. Does this string look like an email address? Does it look like a URL? Second is parsing that text to pull out bits of that information. What is the host name of this email address? What is the +4 part of the zip +4 code? And then the third is altering strings by pulling out the bits that matched and getting rid of them, or substituting other things in for them. Most programming languages these days support regular expressions in at least some capacity, but you often get a lot of terrible function calls. If any of you in here have used PHP and used regular expressions, it's a whole lot of extra baggage. One of my favorite things about Perl is how embedded into the language regular expressions are. It's one of the reasons why Perl has a reputation for being a great language for doing text processing types of things. The Regex engine is also very optimized, so it's pretty fast to use regular expressions. So the first thing I want to talk about is the Regex grammar. This is the programming language, what you use to define a regular expression. A regular expression is, think of it as a string surrounded by slashes. So you can also put pattern modifiers after the slashes. We'll get to those. A simple one like that, Bob, will match Bob, Bob's a guy, all these strings. It'll match any string where Bob is a substring. Note they're case sensitive, so it won't match lowercase bob, uppercase bob, etc. That's just index. But you can add additional things to give yourself more capabilities. The first of these is quantifiers. Quantifier says match some of a subpattern. There's 4 types. The first one is plus. It means match a subpattern one or more times. So ISS plus will match Kissimmee, Mississippi, Miss, all those things, but won't match any string that doesn't have an ISS in it. Note that in this example, only the first ISS is what was matched. It only has to match in one place. Quantifiers apply to just a single subpattern, which all else being equal is just one letter. So A, B plus matches A, B, A, B, 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 etc. If you want to make a bigger subpattern with more than one letter in it, you can use parentheses. So AB plus matches AB, 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 and so forth. If you put other stuff before and after your plus sign, you can make a more complex pattern, such as this. Have a very plus nice day. Will match have a very nice day, have a very, very nice day, etc. And strings that have other stuff before and after the have a and a nice day. But it has to have all of these 3 things in it. That's the first very important thing to remember. When a pattern is being matched against a string, all the subpatterns have to match in order and adjacently. for the overall string to be considered a match. So the string nice day, very have a fails to match because the subparts are all there, but not in the correct order. And have a completely very good and nice day fails to match because the subparts are all there, but they're not adjacent to each other. You also have to be careful of spaces. To the regular expression engine, the space is just a character, so it's perfectly happy to replicate the spaces incorrectly for you. So in this example, where we didn't put the space inside the parenthesis, you see the strings that are actually matchable look like that, which is probably not what you intended. The second pattern, the second quantifier is the star, which means 0 or more. This will still match all the strings up above, but also will match strings with 0 occurrences of ISS in them, which is every string you can conceive of, so it's obviously not very useful by itself. But again, you put additional parts of the pattern before and or after, and now you can also match a string which looks like this. Second warning on spacing, be careful, because if you leave it out, now the string that matches has to have 2 spaces there, one for here, one for there. The third quantifier is question, which says 0 or 1, or optional. So have a very question nice day will only match these 2 strings. Either the very and the space is there, or it isn't, no other choice. Final warning regarding space. Braces allow you to do arbitrary quantification. You can say, I want exactly count of a subpattern. I want between min and max inclusive, min or more, or up to max, starting at 0 or 1. So here's some examples. These will match 3 times, will match vary 0 to 3 times, 1 to 5, and so forth. Alternation allows you to choose from a list of possible choices. So this regex will match any string that includes man, bear, or pig. Note that you need to use, pardon me. This with the alternator is equivalent to having parentheses around it. Like any programming language, regular expressions have precedence, and alternation has very low precedence. So these characters, each of which is technically a subpattern being glommed together, has higher precedence than the alternation. In a string like, in a regex like this, that's pretty intuitive, that's what you would expect. But when you start throwing spaces into the mix, it doesn't necessarily look as intuitive. So this pattern, A space B, pipe C space D, kind of looks like it might be an A, followed by a B or a C, followed by a D, but it isn't. It's A space B or C space D. So to the regex engine, that's very intuitive because spaces are just another character. But to our feeble human brains, that looks a little maybe not what you'd expect. So always feel free to use parentheses to clarify exactly what you mean. Character classes allow you to say that this specific character should be one of a list. There's a number of built-in ones. Whack S means a space character. Whack big S means any non-space character. And in general, the whack big is the opposite of the lowercase one. So whack D is a digit, and whack W is a word character, letters, numbers, and underscores. And a dot, a period, is any single character except midline under most circumstances. You can also define a custom character class using square brackets. If you put a character in it, it means it's part of the class, and you can use dash to specify a range. Remember that ranges are ASCII-betical, and there may be other stuff hiding in that range if you're not careful. You can just put more than one character or range next to each other in the character class, and Perl will figure out what you mean. So 1, 3, 5, 7 matches a single odd digit. A through M lowercase matches a lowercase. That's uppercase. And then this matches either lower or uppercase. If you put a caret as the first character of your class, you actually define a complement class, which is everything other than what you specified. So this is anything except an uppercase letter. This is anything except a vowel. And remember, it's ASCII-medical. So everything except a vowel doesn't mean a consonant. It means a consonant or a digit or a punctuation mark. You can put the named character classes inside your custom class. So WACD A through F is a hex digit. So just another touchback to the ASCII-medical thing. Be careful when you're mixing upper and lowercase letters. If you do this, capital A through lowercase z, that will work fine. It will match all your letters, but it also matches that half a dozen characters that are in between the upper and lowercase letters in the ASCII table. And I'm so happy that whoever invented the ASCII table decided to put those in there. An important thing to remember about your character class is that no matter how long it is, it only matches one character in the string you're trying to match. So this pattern, which could have been better written, has 26 characters in it in the class, but it only matches a single uppercase letter. If you want to match more than one character in your class, you have to use a quantifier or replicate the class like that. So, as I just alluded to, you can of course use quantifiers and alternation with your character classes. So WACD brace 5, and then optionally a dash and WACD brace 4 matches a US zip code, 5 digits, and then optionally a dash and 4 more digits. So remember that dot means any character besides new line. So this, have a dot star day, will match anything that starts any substring, any string that has in it, have a followed by day with anything in between. So have a nice day, have a very nice day, have a Tuesday, have a rotten day, and anything else. Dot star is a very common idiom in regexes to mean a bunch of stuff here. So if you're trying to capture a line of text that begins with something that looks like a date, but you need to capture the whole line, you'll say WACD2 dash WACD2 dash WACD4 dot star. It means get the whole line, but only if it starts with a date. Note that classes are more efficient than alternation, so use them if you can. AEIOU in a class is faster than doing this alternation. Of course, we're talking microseconds faster, but still. Okay, anchors. Anchors match a condition or a position within a string. They do not match characters. Caret matches the beginning of the string, and dollar matches the end. If you have slurped an entire file into one string with embedded new lines, then you have to be a little more careful about this. They match the beginning and end of the string, not the line. But you can use the M pattern modifier to say, no, I want them to match at the beginning and ending of each line within that large string. We'll talk about pattern modifiers more. Okay, so for examples, caret high will match any string that starts with HI. Hi there, history. But won't match any of these strings which have a high in them that isn't at the beginning. Or this one, because of the case. Similarly, ST dollar will match any string which ends with ST, but won't match these other strings which have STs in them, but not at the end. So you can, of course, use them both. So remember this example from back in our early days of 10 minutes ago. Have a very plus nice day. So this will match all of these very thoughtful sentiments, but also this. Because we weren't specifying that nothing came before the have or after the day. So if you put your anchors there, now the have has to be at the beginning of the string, and the day has to be at the end. So now you will only match strings which look like this. Remember that the anchors don't match characters. This doesn't say there's a character at the beginning of the string and then an H. It just means the match starts at the beginning of the string. Another little note on the dollar is it matches at the end of the string before a new line, if one is present. So caret hello dollar matches hello and hello with a new line at the end as if you read it in from a file. All this really means is that if you read in a file and then start to do regex matches on the lines, it doesn't matter whether you chomp the file or not if you're going to do your match to pull parts out of those strings. So don't waste the CPU cycles. The next anchor is a word boundary. So consider the string A, B, under C, space, dot, X, Y, Z for some reason that I can't imagine. The words in this, according to word characters, are A, B, underbar C, and X, Y, Z. It's often very handy to know when these start and stop. So WAC B matches at a word boundary, which is the position between a word character and a non-word character, also the beginning and end of the string. So the WAC B matches at the beginning, after the C, after the dot, and after the Z. No, I'm missing the exclamation marks up there. Note it doesn't match between the space and the dot, because that's not a word boundary. It's in the middle of a string of non-word characters. So the pattern it will match any string with it in it, including all of these. But if you're looking for strings which contain the word it by itself, you have to put the word boundary characters before and after it. And now it will only match these strings which have the it as a separate word. Or you can use WAC big B, which remember, for most of these things, the capital is the opposite. So that's a non-word boundary anchor, meaning not the position between a word and a non-word. So this will match strings where it is not at the beginning or end of a word, so it has to be in the middle of a word. If you want to match any string that contains any word that contains it but isn't it, you have to do this, where you look for it and then the condition of there being not a boundary there or the opposite. And just remember the anchors don't match actual characters. They just match a condition at the point in the string where you're trying to do your match. You've probably noticed that we've discussed a lot of characters like brackets and slashes and carets and dollar signs, which you may show up in strings you're trying to match. So of course you can escape with a backslash any of these characters in your pattern in order to match against them literally. So if I want to match Perl array indexes like that, this is the pattern that you would use. So that means the beginning of a string followed by a literal dollar sign, a letter or underscore, because remember arrays can't start with a number, followed by 0 or more word characters, literal bracket, 1 or more digits, literal close bracket, end of string. That will match strings which look like this. Note that the first dollar sign is escaped because we mean it literally, but the one at the end is not escaped because we mean the end of string anchor. Similarly, these brackets are escaped because we mean them literally, but these brackets and these brackets are not escaped because we mean them to create a character class. So similarly, this pattern matches, among other things, IP addresses. You use the backslash to say literal dot in between your clusters of digits. Inside a character class, you don't have to escape anything except brackets, slashes, and backslashes. You don't need to escape the dash that creates a range. Just stick it at the beginning or end, and Perl will figure out that you mean it literally. You don't need to escape the caret. Just put it not in the first position, and again, Perl will just magically figure out that's what you mean. If you're feeling masochistic, you can look at these character classes and see if you can figure out what they mean. The answers are provided at the end of the slides. If your pattern contains slashes, you have to escape them. It's not usually a big deal, but if you're matching against paths or file names. Sometimes your string is going to have a lot of slashes in it, and this can end up looking pretty messy. So all these slashes you have to escape. You don't have to use slashes to delimit your pattern. You can use actually virtually any character or pairs of braces, parentheses, brackets, etc. So in this case, you can use M, open brace, and then close the pattern here. And now you don't have to escape any of those slashes. So it's clearer. I don't know if I'd go so far as to say that that's very readable. So I've mentioned several times that regexes are case sensitive. You can always literally match an upper or lowercase letter using a character class, but if you have long strings of literal text in your regex, that's pretty cumbersome. If you put an I modifier at the end of your regular expression like this, and then when you use that regular expression, it means treat this pattern case insensitively. So I have a little example. I have some strings here, and I'm going to match them against Bob first, normally, case sensitively, and then insensitively. And you can see that only the first one matches when you're matching in the standard mode, but if you add the I modifier, all of those now match. We're done. That's the whole grammar, sort of. The rules for matching, however, are very important. There's really only two things that you need to remember, though. The first is patterns always match at the leftmost position in the string possible. The reason for this is because the way the regex engine works is it starts at the first character and sees if it can make a match. And if it can't, it rewinds, goes to the second character, tries again, and so forth. So it's always going to find the leftmost possible place. At that place, it will match as much as possible. So patterns match the longest leftmost substring. And the other thing to remember is that when you have a pattern with more than one subpatterns in it, they always have to match in your string in order adjacently for the overall pattern to be considered a match. So now we can move on to some of the things you can do with regexes. And the first thing you can do is store them. All of the examples that we've seen so far, you're just in line in your code, matching a variable or a string against a pattern. But you can store them in a regular scalar variable using QR. And this will define the regex and, as a helpful side effect, parse it to make sure that it's syntactically valid to the regex engine, and store it in this variable. You can now use that later on in your code just like that. So like any other form of encapsulation of code reuse, this is, I would consider this a best practice for anything other than a very short, simple regex, just to see if the string, starts with a letter or something. I also recommend naming them with $RGX or something like that. That's our standard word work, just because that way people will know what this is. You won't try to just print it out. Although you can print it out and get basically the text of the regex back. Another thing that this is really good with is when you want to use the X modifier. So we'll talk about that more later, but if you put an X as a modifier, it allows you to put spaces in the regex and comments. And it allows the regex to extend across multiple lines, which is a great way for making it more readable and understandable and explaining what on earth you were thinking when you wrote this regular expression. That's very cumbersome doing it right in line, but when you bump them all up to the beginning of your program, or you put them off in a module, you have all the space in the world to write it out carefully with explanation of what's going on. Okay, so the primary operations that you do on a regular expression are, first, matching. Does this string look like this pattern? Most of the examples that we've seen so far are that. You do this using the equal tilde operator, pronounced matches, and you put your regex with an M on the front of it. You're not required to use the M for regular matching. I find that it's clearer when you always use the M to more clearly differentiate it from other regex and regex-like operations. So we have our list of strings, and in code we're just going to say if string matches this regex, which is a consonant vowel one or more, we're going to print that it matches. So you can see banana and potato match this arbitrary pattern. In scalar context, typically Boolean context, your match returns true if it matches, false if it doesn't. In list context, it returns more information, which we'll get to. There's a does not match operator, bang tilde, which is just the opposite of matches. Typically would only be used in a Boolean context. You can match against non-L values. So if you have a constant string or a subroutine that returns a string that you want to validate, you can do that. Another modifier that you would use for matching is G. G stands for global. What it does is called a progressive match. So if you have a string and you match it against a regular expression with the G, so this one matches one vowel, when you call it repeatedly, it will match again and again later on in the string until it can't match anymore. Sort of like calling each on a list. So similarly, you can match a vowel followed by another character, and it will match in these three places. Note it can't match the O anymore because there's no character there for the regular expression to match. An important thing to note is that when you do a progressive match, it has to be, they can't overlap. So if you match a vowel followed by three characters, you can match in these three places: A, B, C, D, E, F, G, H, etc. If you try to match a vowel followed by four, you can still match A, B, C, D, E, but then your next match will start at the I. You can't match at the E because the E character has already been subsumed by the first match. Another important note is that if you use positional anchors, particularly the caret and dollar to mean beginning and end of string, progressive match typically will not do much because you can only match the beginning of the string in one way. The exception would be if you're matching repeatedly against lines in your slurped-in file. So, an example, this string has some numbers embedded in it. I'm going to loop forever, match against digits globally, and I will print out that I found a match until I have no more matches. And I found matches at ending at position 7, 18, and 34. If anyone would like to count, feel free. Note this pause function, which when you call it on a string which has been matched against a pattern with a global match, tells you where it has left off. So where the next match is going to start. It doesn't tell you where the last successful match occurred. You have to get the match text back out and run a length on it if you want to know that. So just again, when you're using progressive match, be aware of positional anchors. Be aware of non-matching stuff in between your pattern. This pattern here just matches digits. So after it leaves off here, remember a pattern can match anywhere as a substring. So once it's matched up to the 47, it has this whole string to work with, and it just can match the next set of digits. But if you have other stuff, if you specify interstitials or stuff that must become before and after, remember that may not work with the global match if the before and after is the whole string, not each individual match you're trying to make. Okay, the next thing you can do with regular expressions is substitutions, and this is maybe the most important thing that they can do. Instead of an M, you use an S, and after the first slash, you put a replacement, and you use the same operator. The replacement is treated as a double quoted string, and it's typically literal text maybe with interpolation. So if your string, Bahama Mama, I'm going to substitute Ma with Pop. And I get this. Note it only did one. It only did the first one. Regardless of context, S returns the number of matches made. Doesn't make a lot of sense to call it in list context. But in Boolean context, this helpfully evaluates to true if at least one thing was substituted and false if nothing happened. It will always be either 0 or 1 because it only does one substitution unless you use the global modifier, spelled the same as the global modifier for progressive match, which now, if you do the exact same substitution, Ma for Pop, but with a G, it will replace all of them and tell you it made 3 replacements. A very important thing to note about S is that it is destructive. It modifies the string that you call it on. As of Perl 5.14, I believe, they introduced non-destructive substitution, which returns the value after substitution, using the R modifier, I believe. You also can do something called substitution en passant, which you assign your original string to the string you plan to modify in one operation, and then call your substitution. So this is maybe not super intuitive to look at. It's one of those Perl idioms. What you get when you do this is your original string remains unmodified, and your modified string is modified, obviously. This is very helpful for if you need to take an L value, a non-L value, and do substitution on it. Because S is destructive, you can only apply it to L values. So if you need to take the return of a subroutine and do some substitution on it, you can't do it in place with the actual return value. You have to assign it someplace first. If you try to do it on a constant string, you'll get that error. Okay, so I'm going to skip over split. Suffice it to say that when you use a naive split with just a character, if there's other stuff in your string you're trying to split, it will end up, it's perfectly happy to include that in the fields you get back. You then have to do additional trims or processing on those fields. Regexes allow you to do a dynamic delimiter, which will match, in this case, comma with some spaces. So in that case, you don't have to do any of that subsequent cleanup. If you write a regular expression with those parentheses in it, in addition to being used for grouping and precedence, they also have memory. Which part of the string corresponded to the subpattern inside those parentheses when it was matched is captured, and you can access it after the match. This is how you use regular expressions to parse strings and to pick out parts of the string. The match variables $1, $2, etc. contain these submatches. $1 corresponds to the first set of parentheses coming from the left, $2 from the second, etc. They skip $0 because it means something totally different. If you need to go higher than 9, you should consider not doing this. So, if you have a phone number string and your regular expression is parenthesis, 3 digits, close parenthesis dash, parenthesis 3 digits, and so forth, after you've done your match, your submatches are in $1, $2, $3. And so you see there those 3 chunks of the string which match those 3 parenthetical expressions. If the pattern doesn't match, the match variables won't contain any useful information. So typically you want to, as you do in this example, make sure the match works before you try to use those variables. In list context, if you do a match, it returns those variables, $1, $2, $3, as a list. So if you have a pattern which looks for two vowels and and each one is its own submatch, and you match that against this string in list context, what's going to get returned are the I and the E, which are the two subpatterns from the place where it matched. And often you can use, this is a great time to use array slices. If you need to get one or more of these values out, you can pick them out of that list that it returns. If you also use the global modifier in list context, it will return all the submatches for every place that it matched. Sometimes that's what you want, but in a lot of cases you now have to figure out how to parse that apart. So I find it typically is better to call using the global match repeatedly in list context. I'm sorry, it's better to call an array context without the G repeatedly until the match fails, rather than do it all in one giant blob and then have to do that afterwards. If your pattern doesn't contain any capturing parentheses, evaluating the match in list context doesn't typically make sense. But if it's a global match, it will now return all those places where the global match succeeded. So if you have, note there are no parentheses in this pattern, it's matching two vowels. If you match it against this string in list context globally, it will give you the IE and the EA, which are these substrings which it matched as it progressed down the string, being called repeatedly. You can use the match variables in the replacement string. So if you take a first name with salutation like this, and you, I should say a United States first name, last name with a salutation, you and then capture the first name as $1, capture the last name as $2, and then substitute everything you matched, which includes that salutation, with 2, 1, which has the effect of replacing Mr. John Smith with Smith, John. Note, the part of the string before where the match started to happen is unaffected by this. Substitution only substitutes for the part of the string which it matched. If there's other parts of the string before or after, they're left untouched. You can even use those submatches later in the same pattern, referring them as whack 1, whack 2, like that. So if you're looking for your text with repeated characters, you can look for word boundary, some letters, one or more spaces, and then the contents of that first subpattern. So this will find in the repeated string the repeated use of the word the. This is called back referencing. If you're using Perl 5.10, you also can name your capture buffers using parenthesis, question, angle, name, close angle. And then the thing you're trying, the subpattern you're trying to match. So if you're matching phone numbers, you can name the first capture buffer as area code. Notice there's another capture buffer here, which we aren't going to care about. And then the area code is optional, and then you have another named parenthetical expression, which matches the main part of the phone number. So when you parse a string that looks like a phone number with an area code, that will be captured. And you can get these in the wonderfully named %+ hash. So later in your code, you can print out that the area code was $% brace area code. Isn't that great? One could argue it's somewhat clearer than $1. You also can print out the number this way. And like any other pattern, if it doesn't match at all, nothing will be captured. So always check that the match worked before you try to access those things. So here's the output of that. When you parse this number, you get area code in $+ area code like that. You can also back reference with these using whack G, brace, and then name. So this is how you do that repeated word from up above. Named capture buffers arguably create more readable code, so use them if you're using Perl 5.10. If you want to cluster for clarity or for precedence reasons, but you don't want to capture, you can spell your parentheses, open paren, question, colon, close paren. And now those parts of the substring, of the subpattern, will not be captured, but it still counts as parentheses for purposes of precedence and grouping. Which match variable contains what depends on whether they were used in the match. So if the thing inside the parenthesis could match 0 characters, and that's how it turns out, it will end up empty. If it's not used in the match at all, because, for instance, it's on the wrong side of an alternation, it will be undefined when you're done. And I have this horrendous example here, which you can peruse at your leisure, if that's how you spend your leisure time. An important note is that these match variables persist only until the next successful pattern match, which you might not even realize is happening if you call a subroutine that happens to do some pattern matching. And it happens even if the pattern successfully matched doesn't do any capture. What? So here's an example. We're going to match this string against a pattern to do some capturing. And then we're going to print out these match variables. So here's the successful match. I'm going to match A, and then some stuff in the X, and then some stuff in Z. And I'll print the match variables, which notice these are special globals, so you don't need to actually pass them. But you should. And then I'm going to match against a string that doesn't match, a pattern that doesn't match, and then I'll match against a pattern that does match, and does some capturing, and then I'll match against a pattern that matches, but does no capturing. And you'll see that they start out undefined. After this first successful match, they're defined, or most of them are defined. After the failed match, they're unchanged. After a successful match, they're reset based on the pattern. After a successful match with no capturing, they're all just cleared out. The takeaway here is when you do a match, if you care about the match variables, you should assign them to another variable right away. First thing after you do your match. Especially because, as I said, you might call a function that does some matching you're not even aware of, and that can clobber your match variables. So just like the first line of every subroutine should be unpacking under into some variables to actually use in the subroutine, the first line after you do your match should be unpacking those match variables and putting them into variables that you will then use. It's also obviously much clearer to use dollar operand and whatever instead of $1, $2. I'm just going to briefly say you can interpolate regexes into other regexes, which is great for building up complicated regular expressions from simpler parts. No one wants to look at the regular expression that matches an arbitrary URL, but you can build up a regex that matches a host name, a regex that matches a protocol, a regex that matches a file path, and then in your code, the regex looks a little more manageable. And there's a couple of brief notes. When you interpolate, if you interpolate plain strings, the regex characters are treated as regex characters, not as literal text, unless you escape them with quote meta, like that. Another important note when you're interpolating, if you're using capturing, is that 1, 2, 3 counting from the left is counted when all of the interpolation is done. So a regex, when you match it, may have certain parts of it be 1 and 2, and then you interpolate it into a regex with other parentheses to the left, and suddenly those parentheses have different numbers. So be aware of that. Obviously, named captures gets around that problem. I don't know what happens if you interpolate a regex with named captures into another regex that has the same names for captures. Don't do that. The other thing, of course, is if you're using positional anchors, be very careful when you're interpolating regexes. Because if you interpolate a regex that starts with a beginning of string anchor into the middle of the pattern, probably it will never work. This is the /x modifier. So as you can see, instead of this regex, which that's not even that complicated, that matches integers, you can spread it out, explain exactly what you're doing, use indentation, use white space. This is arguably a lot cleaner to understand, but as you may recall, putting this giant blob directly into where you match it in your code is not great. So put these off in a module or up at the beginning of your program. But use X if your regex is even a little bit complicated. Quick summary of the pattern modifiers that we've talked about. I means match insensitively. S, all it really does is include n in the dot class, which may be useful if you're looking at a large line of text that represents a whole file. M means that caret and dollar match based on embedded new lines. X is extended regex. G is matched globally, and then there's some other modifiers which we're not going to talk about right now. All right, a few tips. Remember, patterns match longest, leftmost, in order, adjacently. Remember those two things. Try to develop your regular expressions a piece at a time and then build them up using interpolation. There is nothing that's worse to debug than a 500-character regex. It's the worst. But if you have individual sub-patterns, you can check each of them individually, and it gives you a much better idea of what's wrong. Remember, if you use match variables, that all parentheses memorize things. Remember that word boundaries and other anchors match conditions or positions, not characters. Don't reinvent the wheel. There's whole swaths of CPAN devoted to pre-done regular expressions for URLs, email addresses, and just about everything else. Try to keep your regexes as simple as possible and single functional. I could write a regex that would match any arbitrary set of digits delimited with dashes and use it to match social security numbers, zip codes, and phone numbers. But that's terrible. Give clear names to your regex expressions that you store in variables. I like using some kind of a prefix. And name them based on what they do, not how they do it. If you have regex zip code instead of regex 5 digits, then when you decide to add support for zip +4 or Canadian postal codes, your name still is correct. Regular expressions are extremely powerful, but they're also, as you have seen, somewhat more complicated and harder to understand than your basic string functions. So if Perl has a built-in string function that does exactly what you want, use it. Don't use regexes just to see if a string equals another string. Use EQ. That's why we have it. Similarly, use index if you have that capability. These are all these string functions are much faster anyway. They're super duper optimized. This is all the stuff that didn't even make it into these notes, let alone into the talk. And you saw I had to skip some things because I only had 50 minutes to talk about this very long topic. So my email address was up at the top. If you have questions about anything regex related, feel free to shoot me an email. Here's the answers to the discussion questions, including those brackets. And wow, I made it. So I hope you don't all hate me. Thank you very much.